This lesson is looking at the properties of real numbers. Basically, this lesson is going to be a vocabulary lesson. The first property that we're looking at is the commutative property. This property works for addition and multiplication. Basically, what it tells you is the order is not important. You can switch the numbers around. So I can say 2 plus 3 is the same thing as 3 plus 2, or 2 times 3 is the same thing as 3 times 2. Okay, you might be asked to give examples of these properties. A numeric example is an example just like what it sounds like. Numeric sounds like the word numbers. So a numeric example is an example that uses numbers. So 2 plus 3 equals 3 plus 2 is a numeric example. If you're asked to give an algebraic example, that's an example using variables. So I could say a plus b is the same thing as b plus a. The next property is the associative property. This also works only for addition and multiplication. The associative property tells you that the group of numbers you do first can change, but the order of the number stays the same. So basically all that changes is your grouping symbols. So if you look at the example for the first one, the addition, it says 2 plus 3 plus 4 equals 2 plus 3 plus 4. The numbers are still in the same spot. The only thing that changes is the location of the parentheses. So the parentheses in the first part on the left are around the 3 and the 4, and on the right they're around the 2 and the 3. It does not matter which group you do first, you should still end up at the end with the same answer. The next property is the identity property of addition. This property allows the number to keep its identity. So the only thing that you can add to a number that allows the original number to keep its original identity is 0. So anything plus 0 stays the same. Then there also is an identity property of multiplication. The identity property of multiplication does the same thing as the identity property of addition, except it's not 0. In multiplication, in order to multiply a number by something and have it keep its same identity, the number is 1. So I'm multiplying anything by 1 keeps its same value. The next property is the additive inverse property. This tells you that the sum of two opposites is 0. So basically, when you take two opposite numbers and you add them together, you get an answer of 0. So my example that I have numerically is 2. The opposite of 2 is negative 2. So 2 plus negative 2 equals 0. Algebraically, same concept. A plus negative a still equals 0. There's an inverse property of multiplication as well. This one's a little bit different, however, because it says the product of two reciprocals is 1. Remember, a reciprocal is when you take a number and you make it into a fraction and then you flip it over. So 2 technically is 2 over 1 as a fraction. So if I flip it over, I get 1 over 2 or 1/2. So 2 times 1/2 is 2, or a times 1 over a is 1. I'm sorry, 2 times 1/2 is 1, not 2. Then you have the 0 property. This means anything times the number 0 is always 0. So 5 times 0 is 0, a times 0 is 0. Then you have the distributive property. Now, if I was given the top example numerically, I would not have necessarily done the distributive property, because the distributive property takes the factor on the outside, in this case which is 2, and distributes it to both numbers on the inside. So I'd have 2 times 3 and 2 times 4, and then I can add them together because there's an addition sign in the middle. If you have variables, however, like in the algebra example on the bottom, you cannot do the order of operations first. So like in the numeric example, I would have done 3 plus 4 is 7, 7 times 2 is 14, not done 2 times 3 plus 2 times 4. Sometimes you cannot, however, do that. If you have a variable inside the parentheses with a number, you cannot add a variable and a number because they're not like terms, which we'll get into more later. So I would have to multiply a times b and a times c and then add them together once I knew those values. The last one is a big one with equations, which is where we're going. It's the property of equality. Basically, it tells you if something starts off being equal, and an equation is equal because it has equal signs, if you do something to one side, you have to do exactly the same thing to the other side. If you don't, they will not continue to be equal. So the point in all this is to be able to take your steps and justify, because next year you'll be going into geometry, and by going into geometry, they're going to ask you to do something called proofs, or basically proving why you did what you did mathematically. So in these, you want to take the different steps and look at what you did and then justify it with one of the properties. So if we look at the first line, what it looks like we did here was we added 4 plus negative 4. 4 plus negative 4 they put down here as being 0. So what property allowed me to add 4 plus negative 4 to give me 0? That would have been the additive inverse property. It doesn't matter that it's the additive inverse property. What matters is that you know it's an inverse property. So on that line I would have wrote inverse property. The next thing we did is we took the 3 and we multiplied it by 0. 3 times 0 we substituted down here to equal 0. So that would be the 0 property, because anything times 0 is 0 according to the 0 property. The next thing we did was we multiplied 2 times 1/2. 2 times 1/2, we got the answer of 1. Those are reciprocals, so that is a multiplicative inverse property or the inverse property. So we added the words inverse property on the line. The very last thing we did was we added 0 plus 1 and we got 1. And remember, the identity property of addition tells you that anything plus 0 is always its own identity, so it stays 1. Eventually you will work up to where you are justifying the steps that you do when solving an equation.